Question 3, we're doing it. This is the 2015 free response question. Question 3, let's do it. A shopping mall has 3 automated teller machines. Because the machine has received heavy use, they sometimes stop working and need repair. Let X be the number of ATMs that are working when the mall opens. So this would be all 3 working, only 2 working, only 1 working, and none working. Okay, we kind of understand, we wrapped our brain around this question. X is the probability that at any given time the ATM is working. All right. So it asks first in A, what's the probability that at least 1 is working? Okay, so there's formulas on the probability sheet, but none of them really make sense to memorize because you need to know why the formulas work. And I most of the time just use logic and reason. Okay, so those are the probability formulas. Now, with that said, let's go ahead and let my phone refocus. What's the probability of at least 1 is working? Well, the probability, I usually just write out the numbers here. So here's all my possibilities. This would be at least 1 working. This would be at least 1 working. This would be at least 1 working. So if I say to you, bring at least 1 friend to Busch Gardens, you could bring 1 friend, 2 friends, or 3 friends, right? So at least 1 means all of these. So we could do the complement. We could just subtract from 1, because all these should add up to 1, and I already know that the answer to this would be 0.85. I could do that, or I could go ahead and add these up. But the complement rule is very handy, especially if this went on and I didn't know how far it went. So the probability of 1, only 1 working, plus the probability of only 2 working, plus the probability of 3 working would be all that added together, and 0.21 plus 0.40 plus 0.24 is in fact 80. So 85% of the time, somebody has an ATM in the mall. Maybe not multiple ones to pick from, but there's at least, we can say in customer service, hey, we got at least 1 working on the premises. Now let's calculate what should we expect based on these highly used, highly sporadic, very faulty, breaky downy ATMs. What could I expect? Well, based on this probability, we know that the expected value is the summation of x sub I, p sub I. And so that would be 0 times this, plus this times this, plus this times this, plus this times this. So I'm hoping nobody misses this. Can't miss this. This comes up on the test all the time in both free response and multiple choice. When I do all that, I end up getting 1.73. Okay. And then we always have to ask ourselves, well, does that make sense? And I think it seems to make sense. On average, the middle 61% of the time, you have about 1 or 2. So that number is somewhere between there. So that totally makes sense. I didn't make any math mistakes. Now, part C. What is the probability that all 3 are working given that at least 1 is working? So given at least 1 is working, what's the probability that all 3 are working? So notice that was in the set, and we already know the probability of at least 1 working. At least 1 working was 0.85. And we also know that that was in the set, and all 3 working is 0.24. So we can find the probability of what the conditional probability they've asked of me by merely taking 0.24 divided by 0.85 and getting 0.2824. All right. So, next question. D, given that at least 1 ATM is working when the mall opens, would the expected value of the number of ATMs that are working So I got to write this down. Given at least one working. Would the expected value of the number of ATMs that are working be less than, equal to, or greater than the expected value we calculated from Part B? So we need to calculate the expected value and compare it to Part B. So let's go ahead and do that. If at least one is working, we're only going to look at one working, two working, or three working. And we need to calculate this probability, and it seems as if we've already calculated one of these. So given that at least one is working, what's the probability that one is working? Given that at least one is working, we already know the probability of all three working, 0.2824, right? Given that at least one's working, we know the probability of all three working is that. Notice that's not exactly the same number there. Now let's do the next one. We know what goes in this box because it's given at least one is working, same denominator, but in the numerator it would be exactly two working. So exactly two working would have been 0.40. So if I divide that, I get 0.4706. Okay. Now, last but not least, given at least one is working, what's the probability exactly one is working? So exactly one is working is 0.21, given that at least one is working. So notice how given statements reduce the probability sometimes and sometimes increase because you're shortening, actually it looks like it increased, right? Because you're reducing the size of the denominator. So instead of the denominator being 1 or 100 people, it's only 85 outcomes we're talking about. Now when I divide that, I get 0.2471. Now I can do this times this, plus this times this, plus this times this. And that's what I'm going to do. So my expected value, given that at least one's working, is the same, the summation x sub I, p sub I. So 1 times 0.2471 plus 2 times 0.4706 plus 3 times 0.2824. This expected value ends up being equal to, I gotta type all this in. And the fancy calculator is better because it knows PEMDAS. So 1 times 0.2471, which is the same number, plus 2 times 0.4706 plus 3 times 0.2824. So given you come to work and one is in fact working, I should expect 2. So the minute I come to work and I know one's working, I'm actually expecting 2 to work. Now back to my question. It said, given that you know at least one is working when you show up to work, would this expected value be greater than, equal to, or less than what you got in B? So back in B, our expected value in B was 1.73 ATMs working, and that's less than. So this new one is in fact, I guess I should have done it the other way, the way the question's written. They asked me to compare it. This one is in fact greater than. So that's my answer. And I gotta do it in a sentence. Given that at least one ATM is working, the expected value would be greater. Thanks for joining us.